Welcome back to our channel. In our last video, we explored the basics of machine learning, how machines learn from data, recognize patterns, and improve over time. If you missed that, be sure to check it out to get up to speed. Today, we're diving deeper into the four main types of machine learning algorithms: supervised, semi-supervised, unsupervised, and reinforcement learning. Let's break them down with clear definitions and real-world examples. First up is supervised learning. Supervised learning is defined as when a model gets trained on a labeled dataset. Think of it as teaching by example. Imagine you're teaching someone how to recognize different types of fruits. You provide a dataset with images of apples, bananas, and oranges, each clearly labeled with its name. The learner studies these examples and learns to correctly identify each fruit. In supervised learning, one of the key tasks is classification. Classification involves drawing conclusions from observed data and determining to what category new observations belong. For example, in medical diagnosis, an algorithm is trained on a data set of medical images labeled as cancerous or non-cancerous. The algorithm learns to recognize patterns in these images and can then classify new images as either cancerous or not, effectively assisting in diagnosing patients. Another important task under supervised learning is regression. Regression is about estimating and understanding relationships between variables. It focuses on predicting a continuous outcome. For instance, imagine you want to predict house prices. An algorithm is trained on data that includes the size, location, and number of bedrooms of houses, along with their prices. The algorithm learns the relationship between these factors and can then predict the price of a house that isn't in the dataset, based on its features. This makes regression particularly useful for tasks like forecasting and pricing. Next is semi-supervised learning. Semi-supervised learning is a machine learning algorithm that works between supervised and unsupervised learning, using both labeled and unlabeled data. Imagine a student learning to classify animals. You give them a few labeled images of cats and dogs, but most of the images are unlabeled. The student uses the labeled examples to figure out the rest. In practice, semi-supervised learning is often used in image recognition. Suppose you have a small set of labeled images of different animals, but a large set of unlabeled images. The algorithm learns from the labeled data and then labels the rest, improving its accuracy as it processes more data. Unsupervised learning. In unsupervised learning, the machine learning algorithm discovers patterns and relationships using unlabeled data. There's no guide or answer key. It's like a detective sorting clues without knowing the outcome. A key technique here is clustering, which is the process of grouping data points into clusters based on their similarity. For example, imagine you have data on people's weight and height. The algorithm can group individuals into clusters based on these characteristics, such as identifying clusters of people who are tall and heavy versus those who are short and light. This technique helps uncover patterns and relationships in the data that might not be obvious. Reinforcement learning. Lastly, we have reinforcement learning. This technique is defined as a learning method that interacts with the environment by producing actions and discovering errors. Trial, error, and delay are the most relevant characteristics of reinforcement learning. The model keeps improving its performance by using reward feedback to learn the behavior or pattern. A real-world example is autonomous vehicles. They use reinforcement learning to navigate roads. The vehicle makes decisions, such as when to change lanes or stop at a traffic light, based on rewards like safety and efficiency. Through continuous learning, it becomes better at driving. So to sum up, we've explored the four main types of machine learning: supervised learning, where models are trained on labeled data; semi-supervised learning, which combines labeled and unlabeled data; unsupervised learning, where patterns are discovered without labels; and reinforcement learning, which improves through trial and error. These algorithms are essential to modern AI, driving advancements across industries. If you found this video helpful, make sure to hit the subscribe button and turn on notifications so you don't miss our next deep dive into AI and machine learning. Got questions? Drop them in the comments below and we'll answer them in a future video. Thanks for watching.